Ready? Steady, go.
Hello. I'm gonna teach you about buying cars.
We need to start it over.
Okay.
Because the alarm.
Yeah. Okay.
Three cars.
Okay. Sit down. Yeah. Okay. Good. Hello, Mr. Ryan. Hello, Mr. Eric. Okay. Let's see. Let Daddy talk about. So today we are going to talk easy, simple mathematics problem, which is called buying cars. If we have a list of prices for each car and a budget, let's calculate how many maximum number of cars we can get. For example, like 10,
Faster.
5, 20, 40, 35, and if our budget is 35. So how many cars can we get?
How many cars can we get for
Mm.
here?
This is the list of prices.
3.
3. Why is it 3?
Because you look at the smallest number, then add it by the next smallest number 15, and next smallest number is 20. And what does that make? 35.
Okay, 35. Okay. So how does it work? I mean, what's the razor? Okay.
Eraser.
Okay, so you're right. Yeah, the strategy is to pick the smallest first, and then the next smallest, and the next smallest, until the amount of the money we spend is bigger than the budget, right?
Mm.
Okay, so let's define a function. Define by cars,
Budget.
and as a budget, yes,
Yes.
budget and prices, yeah.
Prizes.
So what do we do at the beginning?
我不知道。
你不知道. We need to make the prices from the smallest to big
你好。
to the biggest, yeah? So in order to that, what we can do is to sort it, yeah?
Yes. Sort.
Sort. And then we sort it. So these numbers are increasing like 2, 3, 5, 7, yeah? Right?
Oh,
This kind of
yeah.
thing. Yeah, I
2,
know.
3, 5.
Okay, so this is sorted. Then we have a budget.
Budget is.
Then we need to do what? We need to have a current amount of money, right? Spend. Let's call it spend. At the beginning, we spend nothing, 0, right?
Mm.
Yeah. Now we need to go through the prices. So for
Ah.
car in prices, yeah. All right.
Mm.
So spend the money, and then we also have the number of the cars we have purchased so far. So we have a number. We call it answer, okay? Answer equals 0. And at the beginning, we have purchased 0 number of cars, purchased nothing. Now, if now we need to say if current spend is bigger. All right?
Yeah.
Maybe not.
If it's bigger,
What? Where's the eraser, please?
return.
Come on, give me the eraser. Where's the eraser?
Use your hand.
Okay, raise the hand. Come on.
Use a razor.
Yes, please.
Just like this.
No. So, for car, each one, maybe we can put it this way. Look, if current budget, yeah, current budget is bigger than the price, bigger or equal than the car, right? Yeah.
Yeah.
Then we need to.
Return.
No, not yet. Then it means that we can purchase the car, right? We can purchase the car. So what do we do if we want to purchase the car? We first of all, we reduce the budget. Yeah, reduce the budget
Yeah.
by car. And then we increase the number. We already, yeah, purchase one more car. If it is smaller than the budget, it means that we can't purchase any more car, right?
Yeah.
Then we just return break, you know the break the loop. So it exits the loop and we return answer. So we don't need this spend, okay? So answer. So this is the number of cars. Look. Ryan, what you doing?
Whore.
Ryan, do you get it? Ryan, you're on YouTube. Come on, be good boy.
Whore.
See it. I'll give
Ryan?
See it.
Yeah, I know. Where's the eraser? So
With
look.
your hand.
Yeah, raise your hand. Can I have it, please? Okay, so look. Let's say we have 100 budget. Budget equal 100, and then the cars like 20, 40, 30, 50, and 90. Okay, so can you tell me how to do it? Price dot sort, then the price will become 20, 30, 40, 50, and 90. Yeah. Yeah. Look, after this, price dot sort, then the price will become this, yes? Okay?
This one is 1 and the
Look,
greatest
and then,
one is
look,
3.
and then we try for car in prices, so now 20, yeah? Is budget 100 bigger than 20? Yes?
Yeah.
Then budget decrement by 20, so budget is 80, and then answer is 1, okay? And then now 30, is budget then 80 then 30? Yes.
Yes.
Then,
Then we stop here.
then will become 50, and then this will become one more, yeah? Okay, and move next. Is 50 bigger than 40? Yes.
Yes.
Plus 1, and then this 50 minus 40, that will become
10.
okay. Is 10 bigger than 50?
9.
No, then I break. So then when I break this loop, this break keyword is to exit the for loop now. So without going any further. So that means break. Yeah?
Yeah.
Break. So let's break, and then we return answer, which is 3. Yeah? Break is breaking. And can you tell me what's next? Continue. What continue mean? This is a pair. Continue means, okay,
Keep on going.
keep on going to next one. Yeah? Without if the loop, there's still something at the end, but we're skipping the rest of the loop and continue to next loop. Okay? Okay? So can you tell me the complexity?
Log n. No.
No? What? N. N is
No,
the number.
log n.
Why? What's n? N is the N is the number of prices. Okay?
Yeah.
Number of cars.
Yeah.
So what's the what are we doing here?
We're adding.
Yeah?
Not all of them.
Not all of them. So we need to,
Yeah,
in the
I know
worst
that.
case, no, in the worst case, so there are 10 cars. If I have $1 million, then I can have 1 million cars, right? Yeah, I know I can have all of the cars, right?
Yeah.
So in the worst case, there will be,
If they're cheap like that.
yeah, in the worst case. So it's, this part is ON, right?
Yeah.
This part is ON because in the worst case, you need to go in through each of the car, right?
Yeah.
But here, remember, here is a sorting.
Yeah.
When we talk about sorting, it's O, N, log N. Okay, so look, this is a good example of the, so, okay, so this is an algorithm, but first part we need to sort it, which is O, N, log N. And now the second part, we need to go through each class to check if it's O, N. So what's the complexity?
O and log
That's
n.
a lot of jewelry.
O, N, log N, yeah?
Yeah.
Why? Yes, it's O, N, log N. Why is not O, N?
Because this part.
It's more dominant, yeah?
Yeah.
So look, if the complexity is O n log n plus n, right?
Mm-hmm.
Yeah. We only keep the most important part. This is dominating because this is more complex than this part. Yeah.
Yeah, like
So
that.
we can skip this part. Yeah. Because this is more important, more complex, time-consuming than n, right? Do you get it? How about if I write another one? O n squared plus n log n. So what can this be simplified? So what's the answer of this? What's the complexity? O n squared, which is bigger? N squared is n times n, and this n times log n. N is bigger than log n, right?
Yeah, the n times n.
So O n squared is bigger than this part. So we remove the trivial part. So the dominating complexity is O n squared. Do you get it? Yes? How about O n cubic plus n squared? So what's this? What can this be? What's the complexity of that?
Uh,
On cubic plus n squared.
cubic.
Yeah, because this is dominating, so this is trivial part. Yeah.
Yeah.
So we don't consider this. You know, when we talk about complexity, we talk about the most time-consuming component of the algorithm. This algorithm contains the two parts: sorting the prices, number of cars, and then going through each car to check if there are still budget to buy it, right?
Yeah.
Okay, so there are two parts. Which part is most dominating? Is the sorting part.
Yeah.
So the complexity is this part, which is O n log n.
Yeah.
Got it? Okay, the last part.
Say goodbye.
Bye.
Bye!
Bye.